Hello, I welcome you all. The problem reads the 300 kg bar B, originally at rest, is being towed over a series of small rollers. Determine the force in the cable when T is equal to 5 seconds. If the motor M is drawing the cable for a short time at the rate of V equal to 0.4 T squared in meters per second, where T is in seconds and is in the range 0 to 6 seconds, how far does the bar move in 5 seconds? Neglect the mass of the cable, pulley, and the rollers. Okay, so we have been asked to determine the force. This problem is coming from the engineering mechanics and dynamics, 14th edition by R.C. Hibbeler. So we have been asked to determine the force in the cable when T is equal to 5 seconds. Later on, we have been asked to determine how far the bar moves in 5 seconds. So two things: distance, how far it moves, the displacement, and its force. All right. So let's calculate the velocity. The acceleration. We write it in terms of t. So we know to say v is equal to 0.4 t squared, and we know that acceleration is equal to dv dt. So this is just equal to dv, which is this dt, and therefore this our acceleration is just going to be equal to a 2 by 0.4 t, which is just equal to 0.8 t. So this is our acceleration. So let's use this to compute the force. So again, here it is, we don't have any friction there. It's just rolling over these series of small rollers. So we know to say when velocity is equal to 0, t is equal to 0 as well for the boundary conditions. So we have the tension force here. Okay, like so. There we go. Okay, so this is let's call this F F F F. Right, and let's say our kinetic diagram for this bar is in that direction, MA. So say applying the equation of motion, our F is just equal to MA. This is summation of forces in the x direction. Summation of forces in the x direction is equal to MAX, in this direction being our reference positive. Therefore we have F equal to MA, and our A is equal to, so replacing this A there, this just becomes F equal to, and we know what M is for the bar, it is 300. Okay, M is equal to 300 kg. So 300 by A, which is 0.8 T. Okay, and therefore F is just going to be equal to, in terms of T, F is just equal to, in terms of T, this is 24, right? No? 240, right? 300 by 0.8, 240, right? So this just becomes 240 T. All right. So what is F at t equal to 5 seconds? This just gives us 240 by 5. So this just gives us 240 by 5. Our F is just going to be equal to 1200 newtons, right? That's 300 by 0.8 by 5. Okay, so found the force. So we need to find the distance that this bar travels in 5 seconds, how far it goes. So we know that V is just equal to ds dt, and therefore our ds is just going to be equal to V dt. So integrate this from 0 to s, from 0 to t. Okay, so this gives us s is just going to be equal to, we know what V is. Our V, we already know it is equal to 0.4 t squared. So we'll plug in our V in there like so, dt. Okay, and then s is just going to be equal to 0.4 t cubed divided by 3, evaluating this from 0 to 5, and therefore s is just going to be equal to, s is equal to 0.4 times 5 cubed divided by 3. So this gives us a 16 point, right? This gives us a 16.67 meters. Yeah, I think we are done. We found how far it goes in 5 seconds, and is the magnitude of the force also in 5 seconds, magnitude of the tension force in 5 seconds. So I think this is about it. We found the force, we found also the distance. So I hope this video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and sharing my channel. Bye bye, and I'll see you in my next screen.